now seen how to deal with the different questions that call for the median, the deciles, the quartiles, and the percentile. Now we want to apply that knowledge which we have discussed earlier and try to put it in the mathematics of the continuous random variables and check how do we use that formula of the median to get the median. If the PDF is simple, how do we first test when the PDF is a compound to determine, because we say a compound PDF is that PDF that has more than one interval, and the very first step would be first test the interval that contains the median, and it is that interval that you use actually calculate the median. So we are going to see an example how do we test the median interval if the PDF is compound, then how shall we calculate the median. If it is simple, we say to go direct and calculate the median using the formula which we quoted in the previous video. So in an example 1, of course we are going to begin with the simple one, then we shall do one perfect example of a compound, and we shall definitely close things to do with median, deciles, quartiles, and percentiles. So in an example, we are saying that a random variable x, has a PDF small f of x given by, so our small f of x is equal to 1 over 8x. This is when x lies between 0 and 4, and it is 0 elsewhere. So what is required from us is clearly find Roman 1, the median, Roman 2, the lower quartile. Now, having found the median and the lower quartile, I guess the class you have the picture of how you can calculate Roman 3, D5, then in Roman 4, the 60th percentile solution. First step, identify whether the PDF is simple or compound. Now we are examining our PDF which has been provided. F of x is equal to 1 over 8x. That is when x runs from 0 to 4. How do we know that it is simple? It must have only one interval. So because this has only one interval, it is simple. We have identified that the PDF is simple. So our f of x is 1 over 8x. This is when x is between 0 and 4. Now once you identify that it is simple, then you go direct to calculating the median. So we are going to let m to be the median. Now if small m is our median, we said earlier that once you are looking for the median, then when you integrate from negative infinity to the median value and you integrate in the PDF with respect to x, the answer should be a half. It is simple. We don't need to look for the median interval because it is one interval. Even the median is going to be between these two values, which is a 0 and a 4. So the median will be found in between there. So when you integrate from negative infinity to the median value, and you integrate in f of x with respect to x, the answer should be a half. Now where there is negative infinity, this formula, where there is negative infinity, you remove it and you put a what? A 0. So when you integrate from 0, where there is m, you leave it because it is what we are looking for, m. Where there is f of x, you remove it and you put this. So it is 1 over 8x dx. The answer should be a half. So 1 over 8 is a constant. You can pull it out. We are integrating from 0 to the median, and we are integrating x dx. The answer should be a half. So we shall have 1 over 8. What you get when you integrate x, you increase the power by 1 and you divide by the new power. So we shall have our x squared over 2, and it is an integral from 0 up to m, which we are looking for. So that final answer should be a half. We are now substituting in. Putting the upper limit, we have a half. We have 1 over 8 into putting the upper limit, so it is m which is first. It is our m squared over a 2 minus the 0 squared over a 2, and the answer is a half. So we are now reducing it and solving it, get m. So we are going to have 1 over 8 now into m squared over 2. The other one refers to 0. All that is equal to a half. So this is 1 times m squared, which is m squared, over 8 times 2, which is 16. All that is a half. So our m squared is going to be 8, which means that m is going to be plus or minus the root of 8. So our root of 8, m is the same as plus or minus the root of 4 times 2. So m is a positive 2 root 2, or m is a negative 2 root 2. Now after getting the two probable values of m, of course one of those values must be the median. But it will be the median if it is lying between the two x values in which the PDF is defined. So we have the first m, which is a 2 root 2. Now before concluding that it is the median, you first ask yourself, is it 2 root 2 between 0 and 4? Is the value 2 root 2 between 0 and 4? If yes, it is the median. This one, it lies in the range, which is given. That means 0 is also equal to x, also equal to 4. Then there is m, which is negative 2 root 2. This one, the fact that it is negative, it does not lie within this range. So this is outside, out of range, which implies that the median will now be a 2 root 2, because it's the only value which is lying in the range from 0 to 4. The other second value of m is outside the range. Therefore, it cannot be the median of this PDF, because it is not defined for the negative part. Then Roman 2. So Roman 2 wants us to generate the lower quartile. So we said when we were introducing this, that the lower quartile is denoted by Q1, and that interval given. So we shall first quote, identify f of x. Our f of x is 1 over 8x. This is when x lies between 0 and 4. And because we are looking for the lower quartile of Q1, then Q1 must be definitely at some point between 0 and 4. So Q1 can be there. So if you want to find Q1, it means when you integrate from negative infinity up to Q1 and you integrate with f of x dx, the answer should be a quarter. We said if it is Q2, you say 2 over 4. If it is Q3, you say it is 3 over 4. Then after that, because we are looking for the lower quartile, we are equating to 1 over 4. Now where there is negative infinity, we remove it, we put the lower limit of the interval. So it will be an integral from 0. The upper limit of the integral, which is a Q1 that we are looking for, of f of x, where there is f of x, we remove it, put this. So of 1 over 8x dx, the answer should be a quarter. So after equating it to a quarter, we are now going to find that Q. So we are going to have 1 over 8 is a constant, so you pull it out. It is the integral from 0 up to Q1 of now x dx. The answer should be a quarter. So we shall have 1 over 8. What do you get when you integrate x? That is x squared over 2. But we are integrating from 0 to Q1, and the answer should be a quarter. Put in the upper limits, we are going to have 1 over 8. If we put in the upper limit, it's going to be Q1 squared over 2 minus, we say we introduce the mini brackets, so minus 0 squared over 2, and all that should be a quarter. So we shall have 1 over 8, which is a Q1 squared now over 2, and all that is equal to a quarter, because 0 squared over 2 is a 0. So we shall have 1 times Q1 squared, which is a Q1 squared, and 8 times 2, which is a 16, and all that is a quarter. So after equating that to a quarter, we want to get Q1. So our Q1 squared is going to be 16 over 4, and Q1 squared is going to be a 4. So it means that Q1 is either positive or negative root of 4, and Q1 is positive or negative 2. So Q1 can be a positive 2, or Q1 can be a negative 2. But now, the value of Q1 should be that value that lies in the interval from 0 up to a 4. So we are quoting both values of Q1. Now the first value of Q1 is a positive 2. And we are asking ourselves, does 2 lie between 0 and 1? Yes. So this is in the range. Then there is another Q1 which is a negative 2. Does negative 2 lie between 0 and 4? No. So this is out of range. Now we must conclude with the lower quartile as that value which lies in the range from 0 up to a 4. So our lower quartile for the given PDF, our lower quartile Q1 is going to be a 2. we are saying that it is simple is because it was defined in only one interval. So when looking for d5, we are going to say when you integrate from negative infinity up to d5, and you integrate in f of x with respect to x, the answer should be, because d means decile, and decile is divided into 5 equal parts. And decile is divided data into 10 equal parts. So because of this d, you just write a 5, then over 10. Over 10, and the value of d that you will get as a result of integrating will be the value of d5. So you will try out that and share the solutions in the email. And then in Roman 4, they want us to get the 60th percentile. Equally for the 60th percentile, we shall first quote our simple PDF. Why quote it? Because we don't want to forget about the lower limit. It's not a must that this one will always start from 0. So if it is a 1, then we will substitute in a 1 where there is negative infinity. If it is a 3, the logic does not change. But you just read what is here, and it's the value that you put where there is negative infinity. So our f of x, the 60th percentile, is the same as p60. So our f of x is 1 over 8x. That is when x lies between 0 and 4. So get p60, we are going to integrate from negative infinity up to p60 and integrate f of x with respect to x. And our final answer will be expected to be 60 over 100. So if you integrate where there is negative infinity, you put the lower limit of the integral. Where there is p60, you leave it because it is what you're looking for, and then integrate and have the final answer. So that is Roman 4. Now, as a trial question, you will think about this one. If the question was saying that a continuous random variable x has a PDF small f of x given by example, because you people are fast learners, we can have it as a trial question and share the solutions and check whether they coordinate. So our PDF small f of x is given by we have 4 minus x. This is when x lies between 0 and example 2. Now we have started with a simple PDF. We want to see if it is a compound PDF. How will you get the interval within which the median lies, and then later how you will calculate the median using that interval. So it says that a random variable x has a PDF small f of x given by, so our small f of x is equal to, so it is a 2 over 3 into x plus 1. This is when x is between 0, it's between a negative 1 and a 0. Then it is a third into 2 minus x. That is when it is a third into a 2 minus x. That is when x lies between 0 and a 2, and it is 0 in a square. So required is find Roman 1, the median. Then Roman 2 is the interquartile range. So we said we can't find the interquartile range first, but first find the upper quartile, then after finding the upper quartile, you find the lower quartile, then you substitute and you have the solution. So me, I am doing Roman 1, and we will use the procedures of Roman 1 to work out Roman 2. By 1, you first get the lower quartile range, and then you calculate the lower quartile, get the upper quartile range, then you calculate the upper quartile, and then you substitute. Now for me in Roman 1, I'm going to get the median interval or the median range. After getting the median interval, I will go ahead